Assalamualaikum and selamat sejahtera. So in chapter 7, solid surface, this chapter will cover surface composition and structure, surface group, composition and the structure, physiosorptions and chemical sorptions, adsorption isotherms, and then the rest of surface process, mechanism of heterogeneous catalysis and its examples. Solid surface is the branch of physical chemistry which is deal with the nature of the surface and also with the chemical and physical process which take place on the surface, which is this study the phenomena of adsorptions, catalysis and colloidal properties. Part 1. Adsorptions. Adsorptions is the attachment of the molecule to the surface. Okay, the presence of the adsorbents and absorbers will generate the absorption process. Okay, adsorbents is underlying material or the substrates, while adsorbers is the substance that absorbs. And then the reverse process of the adsorptions is called as a desorptions. Basic terms that we will use in this chapter, which is interface, defined as any surface is a plane which separates any two pieces in contact with each other. While occlusions is when the absorptions of the gas occur on the surface of the metals. Adsorption is caused due to the unbalanced force of the attractions of free valence, which is present at the solid or liquid surface, have the properties to attract and return to the molecule of the gas or the dissolved substance on their surface with which they come into contact. Adsorption is a surface-based process where a film of adsorbents creates on the surface, okay, which is something stick to the surface. The molecule species that gets absorbed on the surface is known as adsorbers, and the surface on which an adsorbent occurs is known as adsorbents. Common examples of adsorbents are like clay, silica gel, or colloids. Thus, the adsorption is a surface phenomena, and the process of the removal of the adsorbent from the surface of adsorbents is known as desorption. While absorption is a process in which a fluid is dissolved by a liquid or solids, which is absorbance, one substance is taken out within the structure of another. The example of absorption process is soaking up spilled milk with the paper towels. There are three steps involved in adsorption process. First is diffusion to the adsorbent surface, and then migrations into the pore of the adsorbents, and finally monolayer build-up of adsorbents. Adsorption is an exothermic process, which means that energy is liberated during this process. The amount of heat that gets involved when 1 mole of the adsorbent is absorbed on adsorbent is known as enthalpy. The change in enthalpy is denoted to be negative. It is because when adsorbent molecules are absorbed on the surface, freedom of movement of molecule becomes restricted, and this results in decrease in entropy. At constant temperature and pressure, the absorption will occur spontaneously. Adsorption process at solid surface. Okay, sorption is either process of absorptions and adsorptions. Okay, adsorption is the process in which molecule from the gas or liquid phase land on, interacts with and attach to the solid surface. While absorption is one substance enter the bulk or molecule of another substance. For example, gas absorbed by a liquid. While the reverse process of adsorption, which is the process in which absorbed molecule escape from solid surface, is called as a desorption, this is the reverse of adsorption process. Adsorbents or substrates is the solid that provides surface for adsorption, which is the underlying materials. And adsorbents is the gas or liquid substance which are to be absorbed on the solids, which is the substance that absorbs. Okay, the molecule can attach to surface in two different ways because of the different force involved, which is either physiosorptions, involve the physical absorptions, and chemical absorption involve the chemical absorption. Surface coverage is normally expressed as the fractional coverage theta, which is the number of adsorbent site occupied divided by the number of adsorbent site available. The fraction coverage is often expressed in terms of the volume of adsorbent absorbed by theta is equal to V over V infinity, which is V infinity is the volume of adsorbents correspond to the completely monolayer coverage, which is measured at standard conditions, temperature 273 kelvins and 1 atm. The rate of absorption d theta over dt is the rate of change of surface coverage and can be determined by observing the change of fractional coverage with time. The difference between the adsorptions and absorptions. Okay, which is absorptions involve the bulk phenomenon, which is concerned with the whole mass of the adsorbents, while absorptions is the surface phenomenon. The concentration of the adsorbed molecules is always greater at the free phase in the adsorption process, while the concentration is low for the absorption process. And then in terms of reaction rate, the reaction rate of the adsorbent is rapid at the beginning and slows near the equilibriums, while in the absorptions the rate is uniform. Adsorption process involve the exothermic reactions, while absorptions involve the endothermic reactions. The temperature effect on the adsorption process, which is the absorption process works at low temperature, while there is no effect of temperature on absorption process. The example applications for adsorption process is in air conditioning, chiller or water purifications, while for absorptions, the applications is like in cool storage, oil production or refrigerants. Only the surface atoms of an adsorbent play an active role in the adsorption process. These atoms pose unbalanced force, either van der Waals force or chemical bond force. So the residual force field on the free surface, which is responsible for adsorption, is produced. For example, when a solid substance is broken into two pieces, two new surfaces are formed, so the number of the unbalanced force become more. As a result, the tendency of absorptions become large. The adsorption is reversible if the adsorbents can be easily removed from the surface of the adsorbents by physical methods. For example, a gas absorbed on a solid surface can be completely removed in vacuum, whilst the adsorption is irreversible if the adsorbents cannot be easily removed from the surface of the adsorbents. For example, adsorptions of the oxygen on tungsten adsorbent. Characteristic of adsorption process. First, absorption refers to the existence of the higher concentrations of any particular component at the surface of a liquid or a solid phase. Secondly, absorption is accompanied by decrease in the free energy change of the system. So when delta G is equal to 0, absorption equilibrium is said to be established. And then thirdly, absorption is invariably accompanied by evaluations of heat. It is an exothermic process. So in other words, delta H of the absorption is always negative. And then on account of its decrease in the entropy of the gas after absorptions, delta S is negative, means that a decrease in the entropy of the gas after absorption process. For the process to be spontaneous, so the thermodynamic requirement that the delta G must be negative, which is there is a decrease in the free energy. On the basis of the Gibbs energy, which is the equation is delta G is equal to delta H minus T change in entropy, which is can be negative if delta H has a sufficiently high negative value, and probability change in S as a positive value. Absorption process can be classified either by concentrations or nature of the force existing between the adsorbents molecule and the adsorbents. For the concentration dependence, it can be divided either by positive or negative absorption. Positive absorption means that the concentrations of the adsorbent is more on the surface as compared to its concentrations in the bulk phase. For example, when the concentrate solutions of kalium chloride is shaken by blood charcoals, it shows a positive absorption. While for the negative absorptions, when the concentrations of the adsorbent is less than its concentrations in the bulk phase. For example, when a dilute solution of KCl is shaken with a blood charcoals, it shows a negative absorption. Second classification, which is depending on the nature of the force existing between the adsorbents molecules and the adsorbents, it can be divided into the physical or chemical absorptions. Physical absorptions is a type of absorptions in which the adsorbents adhere to the surface only through van der Waals, which is a weak intermolecular interaction, which are responsible for the non-ideal behavior of the real gas. Physical absorptions are relatively weak, reversible, and absorption capable of the multilayer absorptions. For the chemical absorptions, the gas molecule or atoms are held to the solids by chemical bondings. For example, hydrogen is chemical soaked on nickels. Some degree of the bonding between the adsorbents and the adsorbents characterized by the strong attractiveness, and the absorbed molecules are not free to move on the surface. The process is seldom reversible, and there is an increase in degree of specificity, and typically monolayer is formed.